Alright, so I'm Nancy, and I'm going to be talking to you about a tool I created actually for a class to help learn cryptographic concepts. And before I begin, I have a disclaimer that I have to say for my employer, is that these are my own personal opinions that I'm giving in this talk and not those of Cisco Systems. So, yes. Okay, so I'm going to start off with some background about why I did this, and then talk about how to get it, use it, do a little bit of cryptography for a demo so that we have some background. Then we'll do a demo of one problem from my VM, and then we'll look at a lot of resources that are available to learn cryptography. Okay, so I did create this as a project for a cryptography class I was taking, and mostly everyone was doing reading papers, and that was like surveys of cryptographic papers, and I didn't want to do that. So I came up with something interesting. Based on the exploit exercises VMs, which some of you may have seen, like for learning Linux exploitation and buffer overflows and stuff. And so I've been doing those at the time. I was like, why not do something like that for crypto? So anyway, I set it up to teach the concepts with 16 different problems, and they're all supposed to be solvable pretty quickly. One of them may take running code overnight, unlike what I said here. But yeah, I designed them to sort of keep the concept, but not be the annoying, I have to run this factorization thing for 3 days to get the answer. And I designed it to work on Kali Linux, and at first I was going to actually distribute the VM, but it's too big to just give to people. It always seem to get corrupted or messed up, so now it's an install that you can actually install on a Kali VM. And it would probably work on other versions of Linux, but I only have tested on Kali, so no guarantees. So if you want to install it, you need, well, VirtualBox I suggest because it's free. If you have VMware Fusion, also great product. So get a product for VM and create your VM for Kali. And I do suggest a fresh VM because there are probably at least 24 users that it's going to create. And it does do some writing to like var temp and a few other places like that. So don't want to mess up anyone's VM. And then I have the tarball on my GitHub account with the address there. And you can just extract the files. It has absolute paths. So, and then there's a configure script you run, which sets all the permissions and the ownerships and all that sort of thing. So it's pretty easy to set up. So how do we use it? You start by logging into the first level, which is level 0, with the level 0 password. And in each home directory for that level, you have a problem description and README. And then your goal is to use the information at README to try to find the next level's password, which will be somewhere encrypted and done wrong, of course, because if they really did good encryption, you'd never be able to get it. And then you find the next one and log on and get the next problem. So if you have problems, I created hint files, which are, .hint and .hint2 to help you out. And I give reading material in each level in case you just don't know anything about the topic. And the final goal is to get onto the winner account after level 15. So, all right, so now we're going to do I think I'm talking really fast here. So, anyone stop me if they have questions. But I was just going to do a little background cryptography leading up to the demo. Starting quite at the beginning of, okay, your basic problem in cryptography is, of course, the Alice wants to send Bob a message, but there's some adversary, and they can do one of several things to get some information, whether that's just observing it, or modifying it, etc. So that's the basic idea you generally have with going into breaking cryptography, is you're the adversary and you get to do something with the message. And you have the three different properties of the security, and you're obviously trying to break at least one of them, generally the confidentiality. So obviously that's, seeing what is inside the message, but it could be the integrity or the authenticity too. All right, so the demo I'm going to do, this is some terminology for the actual cryptography building up to the demo, but yeah, all pretty easy things, just a little bit of math here on the cryptography leading into the demo. So just that, a set of elements, how we're describing keying something, the length, and what probability is. So these are all probably most people know these, but yeah, that probability is the probability of an event occurring and that sort of thing. So our demo is going to be the one-time pad problem, because it worked out perfectly with the timing for the talk to do the one-time pad problem and my thing. So we'll do a little background on that first. All right, so how does one-time pad work? Probably most people have heard of one-time pad since it's been used since World War II. But basically, first, if we're going with Alice and Bob again, Alice will generate some key. And it is supposed to be uniformly random. So, and it also has to be at least as long as the message she's going to want to eventually send. And somehow she gets this securely to Bob. Okay? And then Alice then wants to send this message M to Bob, so she creates a cipher using that key, which is just XORing the message in the key. And then Alice is going to send C to Bob, and then Bob can recover M from C by XORing C with K, which I wrote out the math there that gets that back. So that's basically how one-time pad works. And what you can see, if you go through a little bit of math, is that it is going to be perfectly secure. So what I'm doing here is we're looking at the ith bit in the cipher, or any bit, and calculating the probability that that's 1. And if you go through the math, which isn't that bad, because it's just you're just substituting in the fact that that's the message on the key, and then knowing that the and turns into multiplication, and the key is uniformly random, so you get 0.5. So you then see that you get exactly a 0.5 chance that any bit in the cipher is 1, and exactly 0.5 that any is 0, which means it's completely independent of the message, and uniformly random, and you get perfect secrecy. So that's the basic definition of the one-time pad, which we're going to use for the demo. Just one little thing. So doesn't anyone ever use one-time pad? And everyone probably knows that's because key has to be greater than the message. So you have to know how big your message is going to be. You have to transfer the key securely. So if you have to transfer the key securely, why don't you just transfer the message the same way that you transferred the key? And you can't reuse K, because if you reuse K, well, you get this gigantic mess of probabilities here that I think is probably readable, but and you can see, if you actually had an example, that you get a correlation between the two ciphers. Like one example I ran came up with 0.31 as your probability, and so you end up with them not being dependent. So you learned information. All right. So that's why you don't want to reuse keys. So now it's time to look at the actual VM. And I'm already logged on and everything here, so In fact, I'm sort of cheating. I'm logged on as root right here, so as opposed to the actual level. But that's okay. So the first step, as I said, in going through the problems is to take a look at the README. And some of these problems can be done with pen and paper, and some of them have to be done using tools, or you have to write your own scripts. So it just depends. So for the level 6 README, it tells us that the level 7 password was created by Jack and encrypted using a one-time pad. And the one-time pad was shared with Mary months ago, but she lost it, and she wants to see if you can send it to her again. And we got the following messages to and from them that are below. And so we see the first one is just her asking for a copy. And then the second one from Jack is saying, I can't do that, but here's a hint. And we see this, IENNFCDBAWUZ with the I love you more between it, the exact same number. So, as the hint. And can't read that, can we? And we know that Mary has the encrypted password somewhere stored in her directory. And we're supposed to try to decrypt it with the message with the information from the messages and log on as level 7. And we noted that they're 2 hint files. So some people could probably go out and solve that right now, but we'll pretend we're not one of them and take a look at the first hint, just to see. So the first hint is just a reading hint, which I said I generally would give, and if you did click that link, it pulls up this article, which I did ahead of time in case the internet wasn't working right. So, and if you did look through here, you'd see that there's history and stuff, but then there's an example of exactly how to use a one-time pad with letters and get a result. So with this information right here, it suddenly becomes pretty clear how to do this problem, even if from looking at it theoretically you didn't see how. So let's just look at this second hint too. And this one is more to the purpose. It tells us that Jack's hint was most likely another phrase encrypted with the same one-time pad, which of course the second you reuse a one-time pad, you break in the security. So you can use the properties of this one-time pad to decrypt the password. So how could you do that? You could do it by obviously going through and doing it by pen and paper, or you could write a little script like this one, that would do it for you with 2 runs. And it's just a simple Python script that will help get us the answer. And as you see, I'm just taking in a key in a plain text. I'm not really doing any checks because it was done really quickly. And then just get the rotate amount, which is, from the key, and then just subtract it off the plain text, mod it by 26, and put it back inside the text. So something like this. And then to actually run it, we need to get we have to actually get the password from Mary's directory too. But yeah, we can create the, it's hard to type holding the microphone. But yeah, we can get the first 2 run and get the one-time pad back. So it's just a matter of Okay, so that's the one-time pad. Now we need to get the password itself. So that was in Mary's home directory. And all the characters mentioned here, or the users are like characters I've created to sort of make it more interesting. There are 8 of them in all. So so listing of her directory. We see the padding directory, the .password file, probably the .password file. Oh. And so then we have a password. So it's encrypted, so we take this. And I don't know if this is the right order, but we'll see in a moment whether we get something that looks like all the passwords are groups of words too, so you can recognize them when you get them. My original version, I chose really good passwords that nobody could guess, and then I realized you would never tell when you actually decrypted it with the trick. So it has gone through several revisions here. Okay, I did that backwards, I think. That does matter. Yes. So we get war is the last, which is a phrase. So a part of a phrase, a sentence. So that obviously makes sense. So we did decrypt the password. Okay. And as I said, you could always go through and do those by pen and paper. I think it's probably more fun if people go through and write the scripts, and you probably learn more. But okay, so yeah.
Sorry, just real quick, what were the assumptions you made? Because you were running with root, so when the user logs in, we're not going to be root.
No, I was just doing that it was easier for me personally to get my demonstration, everything ready. But the permissions, when you log in, the level permissions, like you can only see that level that you're on, so you can only read the README for that. But all the other users, I set their permissions so you can actually access all those directories and any files that you need to access. Some of them you can't, because that's part of it. If you can't necessarily read the code for everything. But so, let's see, what topics can I cover here? I have two. Need to go back to the slideshow, but yes. All right. So I have 2 slides of topics, but I start with easy stuff. Like some simple ciphers and why weak encryption is bad, why you shouldn't make weak. Some of this I was doing because I was thinking you want to try to educate people on what they shouldn't do when using cryptography. So that's why I had problems on weak key choices and weak encryption. Then we looked at, there's some stuff on RSA and using SSL with RSA. We saw the one-time pad and in-sync encryption, which I for some reason like and nobody else does. So I've been told that that's the other people just don't find that interesting. For some reason, when I learned that concept, I liked async encryption, so I did a problem on it. And secret sharing is, of course, fun, and I don't think you normally see those. See, some of the other topics. I have a double encryption problem, public key encryption, a chosen plain text attack problem, a chosen ciphertext attack problem, a pattern oracle. There's a hash collision problem, which, yes, does not take days to run because I carefully made a few changes so it would be something you could learn about hash collisions without really annoying yourself. And a DerbyCon key exchange problem. So, all right. I think I actually skipped a few things I meant to say earlier, but I suppose I can come back to those if I think of what they are. I feel like I left out some things. But anyway, I have a ton of slides about things you can do to learn about cryptography. So these are some free courses out there, and the course by Stephen A. Weiss is nice. You can go out to it immediately. It's meant for beginners, but it has videos, reading assignments, and exercises that you can work, and it's designed for Google in 2007. So it's there immediately. And then there's the Stanford Cryptography 1 and Cryptography 2 course, which are both 6-week courses that you have to register for. The Cryptography 2 course has never actually been run yet, but they're registering for it now. So the Cryptography 1 course is really good. And you get videos, programming labs, homeworks, and you get an accomplishment certificate when you're done. So. And also you do get feedback if you register for the course. So when you turn in programs and stuff, they'll actually give you feedback about how good you're doing or how poorly you're doing. So there are those. And the Stanford courses would also be highly recommended. Now if you want something more in-depth then there's the MIT open courses. They have 8 of them. The 2 that I thought would be most useful I listed there were the network and computer security, which almost completely focuses on cryptography. And also hashes to a large extent, but that's basically cryptography. And then they have a cryptography and cryptanalysis course, which also looked really interesting. The network and computer security is an undergrad course, and MIT is putting all their courses online, so eventually there probably will be videos from what I understand, but they don't have them up there yet. It's just a matter of time, but they have all their assignments, readings, lecture notes up there. The other courses that they have, as I said, there are 8 of them. Some of them are very theoretical, like they have a quantum cryptography course, which is, I can't go buy a quantum computer right now, I'm not sure how useful that would be. But they might be of interest to somebody, See, then there's other resources. As I said, I put together as many resources as I could because it seems that it's hard to learn about cryptography from a beginner's standpoint. The first one, MITRE, who is like a government group, apparently did a capture the flag thing, and they had some videos to help people train for them. So their videos were based on like common exploits you'd see in capture the flags. I actually did use Wikipedia a lot for looking up stuff in cryptography. They actually have fairly good articles about different algorithms if you just want to understand how they work. If you're interested in like the theoretical aspect of a hash collision or something, I can recommend that's the University of Illinois Urbana-Champaign is what the UIUC is, Cryptutor. That's where I took the course I did I took on cryptography. So, and that's a public website though, and they have very good descriptions that explain the concepts. And if you're a developer, an IT person, and you want to know how to use cryptography correctly, I can strongly recommend the OAuth's Guide to Cryptography as probably the best guideline there. Now these are a couple of non-free courses. As I said, this is the one that I took is the one at top, the Special Topics in Cryptography from the University of Illinois. And it is a bit theoretical. And this is what I designed the VM for. And if anyone wants it's part of their online computer science master's program, but you don't have to be a master's student to take their courses. You can just sign up for a course if you want. Although if you do want to get a computer science master's, I can recommend their program to you. It's a great way to meet people who work at top companies. I met people at all over, and so if you need a new job, that's a great way to actually meet people to get interviews. It's just a thought. I got interviewed with Microsoft and Google and Netflix and several other top companies when I started doing that. So, and that's because I did projects with people who worked at those companies in the classes. And then for programming, for programmers and stuff, the Using Cryptography Correctly course from Stanford costs about $600, and it focuses in on that. Okay, now for practicing, if you're a real beginner, you could look at the Pico CTF, made by Carnegie Mellon, which was made for high school students, but if you're new to something, it doesn't matter, that it was made for high school students. You can just go on, it's still online, you can go sign up even though it's over, and work through problems. They had 7 or 8 crypto problems, maybe, at different difficulty levels. So then the MITRE CTF, which they had, you can download the code from that from GitHub and run it yourself. Okay. And then the Mazzano Crypto Challenges, they had 48 real-world problems. You can go to their website and they tell you what to do. You send them an email and they send you like 6 problems, and I've done this one round of these anyway. And then you can send them emails back when you have them, and they'll send you more problems. So, sort of fun. And then the Mystery Twister, the Crypto Challenge Contest, which is 160 problems, and they're divided out into 4 levels, but a lot of the higher level ones are RSA factoring problems, which are going to take forever, and they actually say that you probably need to team up with people for joint computation to get them. So, those... Yeah. So those, I've done some of those problems, so. I don't think so, but, maybe I'm just the only one who doesn't. But anyway, I did speed through this because last night I timed this out to 15 minutes perfectly, and I know I must have left some stuff out because I'm way ahead, but I'll try to, but yes. I wanted to give her my webpage again and say, yeah, this is like the 2nd or 3rd iteration of my crypt exercise problems. So the first 9 of them, they're not in order anymore. I made 9 of them originally, okay? And they've been seen by at least half a dozen people and worked through, so I know they're good. The other 7 have not been seen by more than 2 people. So if people go out, there could still be some glitches in those 7. So you can enter an issue in GitHub if anyone comes up with anything, and I also have the wiki public for discussion. So does anyone have any questions on any of this? So I said I know I left out, I think, several minutes of things.
What background would you recommend for people who are going to attempt to solve the problems on your site?
Well, you can start off with them with like no background. The first couple are really easy. I'll say, and probably the first The first two are simple, and then they get they start getting a tiny bit harder. It goes up by increments. You might need some background to do some of the later problems, but probably going through like the Stanford cryptography course or something like that would give you most of what you need.
Thank you.
Anything else? Yes. Yeah, that is a very good book. I used it myself, actually. So yeah, the Applied Cryptography Handbook, I think it's called, by Bruce Strick. Yeah. I don't know, does anyone actually know any more online web resources that I should include? Because I was trying to compile a complete list, and I would love to know more, because it's always fun to have more problems to solve. What was that website again? DerbyCon.net.
Yeah, that was ugly website, so I apologize. It's not mine.
Yeah.
The Stanford Coursera class is really great for that.
Did you learn a lot from it, you think?
Yeah, it's like crypto and then straight into like probability math, but very good for basically.
Yes. So, yeah, I nervously went through about my first 5 slides, which is why this happened. And with us ending up with extra time. But let's see.
What type of jobs are available for entry or single
CIA, NSA, GCHQ.
They also have challenges like that, pages and track them, they pages of authors. It's pretty advanced stuff, but who's good at that stuff and wants to work in that field, they have these web pages where you have to do these problems. And when you're good at that, they invite you for an interview. Like
Okay.
CIA and GCHQ is pretty like good.
I'm not a cryptographer, I'm a software developer. So this is, I took this course for fun, because I thought it was interesting. And yeah, I created this because I thought it was a good idea to try to teach people the best way to use cryptography, because I think that's a really common fault is people don't use it correctly. That it's a great tool and nobody uses it correctly. And so I really can't say too much about the jobs I know that are in it. Obviously, I mean, there's the obvious government jobs. Besides that, I really can't think of any except for things like what he said. Yeah.
It's not pure crypto, but we get a lot of crypto questions and like really in-depth code stuff. We're for ISEC partners when we're helping design platform applications. And sometimes we work with people at the architecture level when they're designing like a new, like sort of really high-level language.
Mm-hmm.
We have a couple guys that are pretty good at it.
Yeah, I think as a general rule, most companies don't actually write any crypto. That's because it's better to use the known algorithms that everyone thinks work from a good library. So it's probably more all research. But
another good resource too, some of you may have heard of it, it's called riseup.net. And they have a lot of good like PGP best practices because, for example, the GPG, whenever you do a default install of it, there's several things what I would consider insecure about that. Not really the cryptography itself, but out of the box, the way that it gets installed, your message digest default to like SHA-1, which is inherently insecure. you know, it goes over on how you can modify the code inside inside your GNU-PG configuration, where you can make it 256. You can set your encryption algorithms to AES-256. There's several like key things in there that people should really pay attention to whenever you're messing around with cryptography, or even if you're trying to send like secure communications, whether it's over OTR or GNU-PG or whatnot. And then I just stay away from closed source stuff. If you don't have access to open source and the code, and it's not peer reviewed, especially with everything that's been in the news lately, I wouldn't use it.
Yeah. And yeah, thinking of the PGP, it's a lot of people use that incorrectly, or at least they won't go out and verify other people's keys, which is the way it's supposed to work. Is to you know it's trustworthy because so many other people have said this person's key is trustworthy.
Some Linux distributions are even using version 3, which you should disable. That's like older PGP stuff, and it's insecure.
Yeah. Yes.
I talked to somebody earlier today who said that they had generated a PGP key 15 years ago and put it out on the internet, and now they have the problem of having lost it and not being able to make it expire or anything like that. What is the future of that sort of thing? Any comments about that?
I don't know if they have any plan for a way to go out and take your key down.
Well, they're not, I guess.
Yeah.
Revocation's broken almost everywhere.
There was a similar issue with that. They found a pad for a World War II cipher, and of course they don't have the message or anything, so they're trying to figure out what it was from, but they've only got part of it, and they may or may not ever find the rest of the puzzle.
I would stay away from like MIT. It's horrible if you start loading stuff into the repository. Sometimes you'll revoke things and it won't revoke outright. You know, that RiseUpNet.net site that I was telling you about, it has some good information about which ones you should be using, and more importantly, uploading those securely instead of just in plain format. So there's a lot of good information in there about it.
Anyway, I think as I said, I was so nervous, I went through the first couple slides way too quickly and ended up finishing way early. So I'm sorry, and probably left out a lot of information. But I just don't know